Hello everyone, this is Mr. Appel, and we're going to graph this rational here using our understanding of transformations. So let's start by identifying the transformations. This x plus 2 here tells me the h value is negative 2. And just like with all our other functions, whatever was affecting the x was our left and right. We saw the same thing in like a quadratic. If we had, an x plus 2 in a quadratic, that plus 2 meant left 2. Same thing here. This is left 2 units. And then we have the plus 3. And in our quadratic or any of our other parent functions we explored earlier in the year, a plus 3 at the end. Here, I should make this an actual function. That plus 3 at the end meant up 3. That's our k value. And that's up 3. So left 2 and up 3. This is a 1, so A is positive 1, so there's no stretch or compression, and there's no x-axis reflection. Okay, so the next step is going to be to use that to identify and graph the asymptotes. So if we go over to the graph here, the parent function has its asymptotes, the x-axis and the y-axis. Well, if we move left 2, then that vertical asymptote, which would have been at the y-axis, is going to move left 2 units. So we're going to graph that vertical asymptote 2 units to the left, which is the line x equals negative 2. And make that a little thicker for the rest. And then similarly, the up 3 is going to shift the horizontal asymptote from the x-axis, the horizontal asymptote, which again, in the parent function is the x-axis. It's going to go up 3, so it's going to be up here at y equals 3. So y equals 3 is our horizontal asymptote. X equals 2 is our vertical asymptote, and there we are. The next step is going to be to find some critical points. The shortcut here is, since in our parent function, when we were at 0, 0, 1, 1 was a point on our graph, and negative 1 was a point on our graph. So it was over 1, up 1 from the origin, and then left 1, down 1 from the origin. Well, the same thing's going to happen here. I'm going to be right 1, up 1 from where the two asymptotes cross, and then left 1, down 1 from where the two asymptotes cross. So that's kind of a shortcut that everything's going to follow along as we go left and up. But it's useful. It's good practice to actually plug in the x values that are just 1 unit to the left and 1 unit to the right of the vertical asymptote. So since the vertical asymptote is at negative 2, I'm going to plug in negative 3. So I'm going to figure out h of negative 3 and then figure out h of negative 1. And that's going to give me those critical points, my kind of aiming points. So h of negative 3, if I plug that in there, gives me 2. H of negative 1, when I plug it in there, gives me 4. And so those are those 2 points. The next step is to calculate the intercepts. So just like what we've done in the past, the x-intercept is when y is 0, and then the y-intercept is when x is 0. So we're just going to plug those in. We are going to have some fractions to deal with, but it's no different. So the x-intercept is when y is 0, so we set the y equal to 0. And then we're going to solve for x. So let's focus on that. So I'm going to subtract the 3 from both sides. And then to clear out that fraction, I'm going to multiply both sides by the denominator, which is x plus 3. And so on the left side, we have negative 3x minus 9. On the right side, we have, wow, I wrote the wrong thing there, didn't I? Whoops. Hopefully you were paying attention and wondering, what the heck is he doing, Mr. Appel? Sorry, that was an x plus 2. And this over here is an x plus 2. And so this is an x plus 2 and an x plus 2. And that actually should be a 3x minus 6. Hopefully you caught that already and you were paying attention. Okay, moving on. And so the x plus 2's over there cancel, leaves us with 1. We can add the 6 to both sides. We get negative 3x equals 7. Divide by negative 3, and x equals negative 7/3. So our x-intercept is negative 7/3, comma, 0. If I look on the graph, I want to see if this actually makes sense. So negative 7/3, in fact, it's probably a good idea to write that as a mixed number. That's negative 2 1/3, comma, 0. That's probably a better way to describe it. So if we go back and look at the graph, let's see if that makes sense. Well, I'm expecting this graph to do something like this, right? It's going to do one of these kind of deals, that kind of a curve. And so let's just see if negative 2 1/3, 0 makes sense. Negative 2 1/3, 0 is right there, and that absolutely looks like it's where it should be. This is a great way to use the graph to help you check your work. Okay, for the y-intercept, let's plug in 0 for x. So we just put in 0 for x plus 2 this time. I'm going to do it right. So that's 1/2 plus 3, which is 3.5. And so 0, comma, 3 1/2 is our y-intercept. And again, I want to look at that graph and see if that makes sense. So 0, comma, 3 1/2. Let me keep going with the color there. It's right there. And that does look like it's in the right place. So again, we're using those just to find an extra point on the graph to make sure that our graph is kind of doing what it's supposed to do. From that point, now we're just going to sketch the rest. It really doesn't have to be perfect. I'm going to try to capture the shape of that curve, make sure it goes through those critical points, and looks like it's getting closer and closer to the asymptotes. I'm not expecting this to be perfect, but just do the best that you can. Really try not to cross over those asymptotes. That's a big no-no. And that is our graph. That's all for now. Thanks.